Welcome to Collapsed Latents, this week in AI, where we don't just report on the latest breakthroughs. We dissect them. We trace their logic. We ask, what does it mean when AI starts to think? This week, we're not watching AI get smarter. We're watching it learn to reason across sound, vision, and motion, with a depth that finally begins to mirror human cognition. 5 papers. One theme: reasoning isn't emergent. It's engineered. And the tools to build it are now in our hands. So let's dive in, not just into the models, but into the architecture of thought. #1. Step Audio R1. When AI doesn't just hear, it listens. For years, audio models treated sound like a side channel, a conveyor belt for text. They'd transcribe a song, then assign emotion based on lyrics. Sad, because the singer said, "I'm lost." But real emotion isn't in the words, it's in the acoustic texture. The tremor in a voice. The breath before a note. The way a violin bow drags across strings. That's why audio reasoning failed. Models weren't processing sound, they were hallucinating about it. Enter Step Audio R1, the first audio model to reason about the sound itself, not its caption. How? With Modality-Grounded Reasoning Distillation, MGRD, a self-improving loop where every step of reasoning is anchored in actual acoustic features. Pitch contours, spectral flux, attack decay, prosody, even bowing dynamics in string instruments. Instead of saying this is sad because the lyrics are about loss, Step Audio R1 explains. This is sad because of a descending chromatic bass line, sustained low-frequency resonance, and irregular tempo, a sonic mirroring of emotional weight. And the results? 98.7% accuracy on Big Bench audio, outperforming Gemini 2.5 Pro. 96.1% on Wild Speech, beating closed-source leaders. But the real breakthrough? Step Audio R1 Real-Time, a version that listens, reasons, and responds in 0.92 seconds. Why so fast? Because researchers discovered a critical insight. Models only think when there's a reward for thinking. Without a 20% boost for generating a reasoning chain, they shortcut, they pretend to think. With that incentive, they stay in the game. And we fixed a deeper flaw, the I can't hear delusion. A model claiming it failed to perceive audio, even when it had. Using a 2-stage correction pipeline, they reduced self-cognition errors from 6.76% to 0.02%. So here's the truth, audio isn't resistant to reasoning. It's just been misunderstood until now. AI doesn't just hear. It listens. #2. Kandinsky 5, the open-source revolution in cinematic AI. Now let's turn to vision, and the most powerful open-source video generation family yet, Kandinsky 5. This isn't just another model. It's a trinity of capability. Image Light 6B, ultra-high-res image generation. Video Light 2B, 10-second videos in under 10 seconds. Video Pro 19B, studio-quality output that rivals Sora and Veo. But the real magic isn't in scale, it's in data intelligence. They trained on 500 million images, 250 million videos, all cleaned, filtered, and segmented using AI. No watermarks. No blurry junk. No text-heavy bias. Just pure visual signal. For video, they solved the quadratic complexity problem, the bottleneck that makes video generation slow and expensive, with NABLA, Neighborhood Adaptive Block-Level Attention. Instead of processing every pixel, NABLA focuses on motion vectors, edges, and key visual details, like a spotlight, not a floodlight. Result: 2.7x faster training, 90% less compute, same visual quality. But the real win: human evaluations. Kandinsky 5 Video Lite beats Sora in both visual fidelity and motion fluidity. Video Pro matches Veo 3, all open source. How? With comparison-based feedback, a form of reinforcement learning from human feedback, RLHF, at its finest. You don't just train on good videos. You train on better ones by showing 2 versions and asking, which dragon looks more majestic? And speed. Thanks to distillation techniques, latent consistency models, and adversarial diffusion distillation, they generate 1080p videos in just 4 steps, rivaling models that take 100. But here's the kicker: TiViBench VideoTPO and TiViBench Bench, new benchmarks that test true understanding, not just realism. Not does it look real, but does it get the physics right? Because many models cheat by generating low-motion videos to inflate scores. Devil, a new dynamics metric, caught them in the act. So Kandinsky 5 isn't just powerful. It's aware. And it's open. So go build something wild. #3. TiViBench and VideoTPO, the reasoning compass for video models. Now let's ask the hard question: can video models actually think? We've seen stunning outputs, but are they reasoning? Or just pattern matching? Enter TiViBench, the first hierarchical benchmark for visual reasoning in image-to-video models. It doesn't just test how well a video looks. It tests whether it makes sense. 4 dimensions of cognition. Structural reasoning, solving mazes, tracking object paths. Spatial and visual pattern reasoning, completing shapes, predicting occlusion. Symbolic and logical reasoning, Sudoku, transitive inference. Action planning and task execution, robot navigation, goal-directed motion. With 595 curated prompts, it's a full cognitive map of visual intelligence. But benchmarks alone aren't enough. So we get VideoTPO, a test time strategy inspired by LLM preference optimization. Here's how it works. Generate 2 videos per prompt. Use a vision language model, like GPT-4o, to compare them. It gives feedback. This one respects object permanence but misses the color rule. That feedback becomes a textual gradient, refining the prompt, no retraining. And the results? Over 10-point gains on open source models. Hunyuan video jumps from 4.03% to 10.25%. 121 goes from 8.4% to 18.15%. Why? Because reasoning isn't emergent, it's enabled. And it can be unlocked with smarter inference. Even Sora and Veo fail on the hardest tasks, not because they're dumb, but because they compress features too much. They lose the fine details needed for logic. So the future isn't bigger models. It's smarter thinking at test time without touching a single weight. #4. MGRD, the multi-agent team that learns to think together. Now let's scale up. What if we don't rely on one model to think, but on a team? Enter MGRD, a new reinforcement learning framework for multi-agent reasoning systems. Imagine, solver generates a draft. Verifier critiques it. Corrector fixes the errors. Like a human team, draft, review, revise. But here's the catch. Traditional RL fails because of reward noise. If the final answer is right, even if the verifier was wrong, it still gets credit. So the verifier never learns to spot flaws. MGRD fixes this with agent-specific verifiable rewards. Solver, only rewarded if the answer is correct. Corrector, only if the final output is right. Verifier, bonus for catching errors, penalty for false alarms. And for efficiency, agentic pipeline parallelism, like a factory line. As soon as the solver finishes, the verifier starts. No waiting. No idle time. Plus adaptive sampling, the verifier focuses on its hardest cases. The corrector learns from its toughest corrections. The result? QN3-30B goes from 86.5% to 93.3% on AIME 2025, beating even the 235B model. And the best part? The verifier and corrector are transferable. Plug them into other solvers, and suddenly they all think deeper. Because training agents to critique and correct doesn't just improve them, it teaches the solver how to think. So the future isn't bigger models. It's smarter teams, working together, learning together. #5. Gen-ViRe, the first true test of AI world simulation. And finally, the ultimate test. Can AI simulate the world? We've seen models generate videos that look real. But do they understand physics? Causality? Goal-directed action? Enter Gen-ViRe, the first comprehensive benchmark for generative visual reasoning. 6 cognitive dimensions. Perceptual reasoning. Analogical reasoning. Algorithmic logic. Spatial temporal planning. Abstract reasoning, like Raven's matrices. We tested 7 models, Sora Veo, Juan Haluo, each generating 5 videos per prompt. Over 2,500 videos analyzed. And the verdict? They fail where it matters. Sora 2 solves Sudoku by simulating steps, but fails to simulate a robot pushing a stool. It makes doors vanish. Objects teleport. Paper towels appear from nowhere. Why? Because abstract logic not equal to physical simulation. The model sees symbols as visual elements, not logical addresses. It treats D as a shape, not a point. It doesn't ground symbols in space. And in spatial temporal tasks, physics is broken. The model doesn't simulate causality, it hallucinates it. So Gen-ViRe isn't just a benchmark. It's a science of reasoning, diagnosing where models fail, perception, planning, physics. Because if AI is going to build robots, drive cars, or act in the real world, it needs more than visuals. It needs a mental model of reality. So what's the big picture? This week we've seen something profound. Reasoning isn't a feature, it's a foundation. From Step Audio R1, teaching AI to listen to sound, to Kandinsky 5, turning open source creativity into cinematic power, to TiViBench VideoTPO, MGRD, and Gen-ViRe, proving that real thinking requires grounded logic, team collaboration, and world simulation. The future of AI isn't about more data or bigger models. It's about deeper understanding and the courage to ask, does it reason? Because the real test of intelligence isn't how well it mimics the world. It's whether it can simulate it. So if you're building, creating, or just dreaming, go build something that thinks. And if you enjoyed this deep dive, hit like, subscribe, and tell us in the comments, what kind of reasoning system would you build next? Until next week, stay curious, stay critical, and keep thinking. This is Collapsed Latents, This Week in AI. See you in the next thread.